In this section, we're going to continue our work with derivatives, and we're going to focus on two rules, the product rule and the quotient rule. So basically, these rules are just going to be more shortcuts that we can use, as well as more ways that we can actually take the derivative of some other types of functions. So the first thing I want to look at is the product rule. So first of all, if you look at these two functions, x to the third and 2x to the fifth, we want to take the product of these, and we're going to see that how do we take the derivative of the product? So one way is to use basically the power rule, and that's what I'm doing here. So I'm going to start off by taking or finding the product. So multiply the coefficients. 1 times 2 gives me 2. Keep the x, add the exponent. So there's the product. Now find the derivative of this. So I'm going to take the derivative of the product, and I end up with 16, because remember the power rule, multiply the exponent times the coefficient, keep the x, subtract 1, so we get 16x to the 7th. So that's using the power rule, because remember, power rule, you would actually have to you'd have to do the product first, because you always have to have, in order to apply the power rule, you always have to have a coefficient times an x raised to an exponent. So now the question becomes, well, is this the same thing as just finding the derivative of each piece and then multiplying them? So that's what we're going to look at next. So if I find the derivative of the first piece, which would be 3x squared, the derivative of the second piece, 10x to the fourth, and now if I actually multiply these two derivatives, is it the same thing as taking the derivative of the product? So when I multiply the derivatives, I get 30x to the 6th, which you see that these two things are not the same. So this is the correct answer because we applied the power rule. We went through, we found the product so that it was in the format needed for the power rule, where the second method we did was we said, okay, well, is it the same as taking the derivative of each part and then multiply them? And we just saw that it's not. You get a different answer. So this is the incorrect answer. So the question down here asks us if we want to find the derivative of the product of functions, will multiplying each of the derivatives get us the answer? The answer to that question is no, because we got two different answers. So there's got to be another way, because what happens if we can't multiply these easily? Up here it was easy to multiply the two functions first and then apply the power rule. But what if it were something more difficult, like x plus 2 raised to the 6th power times x minus 1 raised to the 7th power? You wouldn't want to have to multiply all that out. So basically we have a rule for it, and it's called the product rule. So here's the product rule. It looks really complicated, but it's really not that bad. It's basically just saying that the derivative of a product is equal to the derivative of the first function times the second function plus the first function times the derivative of the second function. So basically each part here of the product, or basically we're going to take a function and we're going to break it up into two parts, the two products, or the two pieces of the product. So to kind of summarize that for you, the easiest way is going to be to just let one part of your function equal u and the other one to equal v. These are going to be the names of our functions. It corresponds to this formula. And then you take the derivative of each of those pieces. So u prime and v prime would be the derivative. And then we're going to multiply these two from bottom to top. And then we're going to add that to the product of these other two. And I'm just going to draw the arrow from bottom to top because this is going to help us later when we do the quotient rule, or draw this line from bottom to top, because that's what you want to start with for the quotient rule. So I'm going to start with that for the product rule just so that we stay consistent. So basically you cross multiply whatever you get here, and then you add those products together. And that's the same thing as this product rule. So like I said, since multiplication and addition is commutative, you could switch the order of this. So for example, I could do u times v prime plus v times u prime. It wouldn't matter. But I'm going to stay consistent with always multiplying v times u prime first and then adding u times v prime, just because it's going to help us later on. So let's look at this first example, where we're going to find the derivative of this function using the product rule as well as using the power rule. So we're going to use the new method that we just talked about and the old method to see that we get the same answers. So our first method for this will be using the product rule, which is the new rule. So according to the product rule, you're going to let u equal one part. So I'm going to let u equal the first part, and then I'm going to let v equal the second part. So u is going to equal 3x squared minus 4x. V will be 2x plus 1. You're going to take the derivative of each of those pieces. So the derivative of the first, we're going to use the power rule to do that. So it's going to be 2 times 3 gives me 6. Subtract 1, so it's just going to be 6x. And then minus 4. And then for the bottom here, the derivative is just going to be 2. So now the rule is multiply from bottom to top. So the derivative, f prime of x, is going to be 2x plus 1 times 6x minus 4 plus the product of these two things. So 2 times 3x squared minus 4x. So now, yes, this is the derivative, but in order to show you that it's the same as using the power rule, I'm going to go through and simplify. Normally, you don't always have to simplify. You might just be asked to leave it like this. But if I wanted to go through and simplify, I'd have to FOIL this stuff or multiply this stuff out. So I would get 12x squared plus 6x minus 8x minus 4 plus 6x squared minus 8x. Combined your like terms here, so I have 12x squared plus 6x squared is going to give me 18x squared. So those I combine. 6x minus 8x will be negative 2x minus 8x will give me negative 10x. So those are gone, and then a minus 4. So this is the derivative. So now I'm going to do this, but I'm going to do it a different method using the way that we would have done in section 2.1, which is using the power rule. So according to the power rule, in order to be able to use the power rule, you have to get your function into the format of a coefficient times an x raised to a power, and then addition and subtraction between those terms. So the first thing I would have to do with this is I would have to rewrite f of x. So let me just first bring it down. And then I would have to actually multiply this out because you can't apply the power rule until you have those individual terms. So multiply this, you get 6x to the third minus 8x squared plus 3x squared minus 4x. And then you can combine like terms. So 6x to the third minus 5x squared minus 4x. So now I can actually apply the power rule. So I'm going to find the derivative. So it becomes f prime of x. So 3 times 16, 18x squared. 2 times negative 5 minus 10x, and then minus 4. So you can see that you get the exact same answer using both methods. So at this point, it's really going to be a preference. Would you rather multiply out first and then apply the power rule, or do you want to just go right into the product rule? Totally up to you when it's a problem like this. When they become more complicated, you're going to see why the product rule is going to be important. So in the end, remember, finding the derivative of a product is not the same as finding the derivative of each individual piece and then multiplying them. You have to use this product rule. You have to use this combination in order to get the same answer. So let's look at the next page and try some of these examples. So for the first one here, notice that we have a product to start. We have this times this, and then we have this extra piece that's just being added at the end. So that extra piece at the end, we're just going to have to make sure that we remember to take the derivative of it and add it on to whatever we get from the product. Now, like I said, it's up to you if you want to distribute this x to the fourth and then just do the power rule. You can do that, or you can use the product rule. I'm going to use a product rule just because I want to practice using it with you on some of these easier ones, but it's your preference. So if I want to use the product rule, I'm going to start by setting these up. So u equals 3x minus 9, v equals x to the fourth. Take the derivative of each. So I have 3. This is going to be 4x to the third. Start from bottom to top. So y prime, the derivative, is going to be 3 times x to the fourth plus 4x to the third times 3x squared, or 3x minus 9. And then don't forget about this piece up here. So plus 8 when I take the derivative of that. So now I can go ahead and just simplify this. So y prime equals 3x to the fourth plus, I'm going to go ahead and distribute 12x to the fourth minus 36x to the third plus 8. So then we can combine these x to the fourth, so we get y prime equals 15x to the fourth minus 36x to the third plus 8. And that's it. So B I'm going to leave for you to try on your own. Like I said, up to you if you want to multiply this out first and use the power rule or try the product rule. Up to you. So let's look at one that's a little bit more complicated together. So for this one here, for C, that's going to need a rewrite step first because here I have a product, this times this. And you could go ahead and distribute it through if you wanted, but I think then the numbers or the letters and the variables become more complicated. So what I would do is just rewrite it first, and then we'll apply the power rule. So this is going to be 2x to the negative fifth, since the 5's in the denominator, times 4 times x to the 1/3 because it's a root, plus 2x. So now I have this is going to be u, this will be v. So 2x to the negative fifth, v is going to be 4x to the 1/3 plus 2x. U prime, so multiply, you get negative 10x, subtract 1, so minus 6. And then v prime is going to be 4/3 because you're multiplying that 1/3 times 4 x, and now you're subtracting 1. So really think of it as subtracting 3 over 3, so you have your common denominators. It's the same thing as subtracting 1. So you get negative 2/3 and then plus 2. So now you're going to multiply from bottom to top. So s prime is going to be negative 10x to the negative 6 times this whole thing, 4x to the 1/3 plus 2x, plus this whole thing here, 2x to the negative fifth times 4/3 x to the negative 2/3 minus 2. And that we are just going to leave as is. We're not going to simplify that because those are going to get pretty messy. So D I'm going to leave for you as well. So just make sure you rewrite this first so you have t to the 1/2. And then either multiply it out and do the power rule or use the product rule. Up to you. So let's look at F together because F is a little bit more difficult. So if we look at F, first thing is going to be a rewrite step. So we have, this is going to be 2x to the negative 1/2 because it's a root, so it's 1/2 plus x. Then this is going to be 3x squared plus x to the 1/2 plus 3 pi to the third. So now we're going to go ahead and set one piece equal to u, the other piece equal to v. Like I said, you could try to multiply this out, but I just think it gets really complicated, so it's better off just going right into product rule. It makes it a little bit easier. So u is going to be this first part, 2x to the negative 1/2 plus x. V is going to be this other part, 3x squared plus x to the 1/2 plus 3 pi to the third. Then you're going to go ahead and take the derivative. So I have negative 1/2 times 2 is just going to be a negative 1, so negative 1x. Subtract 1, which is like thinking of it as subtracting 2 over 2. So it's going to be negative 3/2. And then it's just going to be a plus 1 at the end. Take the derivative of this second part. It's going to be 6x plus 1/2 x. Subtract 1. You're going to get negative 1/2. And then just remember this pi at the end, it's just a constant, so it just goes to 0. Multiply from bottom to top to get the derivative. So we have negative x to the negative 3/2 plus 1 times 3x squared plus x to the 1/2 plus 3 pi to the third. Keep in mind when I'm multiplying these, the order that you multiply here doesn't matter. You could switch those. And then, let me just move this over here. And then we have plus this stuff. So we have 2x to the negative 1/2 plus x times 6x plus 1/2 x to the negative 1/2. So there's your derivative. So the next thing we want to talk about is the quotient rule. So quotient rule means when we're dividing. So we're going to look at basically taking two functions as a quotient and applying the power rule to see what we get, and then see if we can just go ahead and take the derivative of each part and divide it, see if we get the same answer. So the first part here, I'm going to use the power rule. So these two functions, go ahead and find the quotient first. So x to the third divided by 2x to the fifth is going to become 1/2, 1 over 2, because this is like a 1. And then keep the x, subtract the exponents. 3 minus 5 is going to be negative 2. So now if I find the derivative of that, so d over dx of 1/2 x to the negative 2, so use the power rule now that we have it in the format for it. Negative 2 times 1/2 is going to be negative 1. X, subtract 1, you get negative 3. So the derivative of the quotient is negative x to the negative third. Now if we switch how we did that and we find the derivative of each individual part, this would be 3x squared. This would be 10x to the fourth. And then we go ahead and we find the derivative, or we found the derivative. Now if we go ahead and find the quotient of this, let's see if we get the same thing. So 3x squared divided by 10x to the fourth. 3 over 10 isn't going to reduce, so it's just going to stay 3 over 10. Keep the x, subtract the exponent, it'll be negative 2. So for this is the answer when you take the derivative first and then divide, versus this is the answer when you divide, then take the derivative of that quotient. So this is the correct answer, and since this doesn't match, this is incorrect. So there's got to be another way to find the derivative of a quotient other than actually reducing first to get it into that power rule format. And the way that we know it can't be is what we just did here, because these don't match. So again, if you want to find the derivative of a quotient, will dividing each of the derivatives get us the answer? The answer to that is no. So you have to do something further. So if it's easy enough to just simplify and divide, then I would just do that so you can get it into the power rule format and then just apply the power rule. But there's going to be times for quotient that you absolutely can't simplify and you have to use a quotient rule. Unlike multiplication, you can pretty much always multiply, but for division, you can't always divide because you're not going to be able to simplify it. So the way to actually go about finding the derivative of a quotient is the quotient rule. So the quotient rule, basically we're going to use those, split it up into our two functions, u and v, and we're going to do the bottom function times the derivative of the top minus the top function times the derivative of the bottom, and then we square the bottom function. So this is a rule that you got to know, and we're going to set it up just like when we did the product rule. So we're going to set u equal to something, v equal to something, take to the derivative of both parts, and we're going to start, like I was saying before, we always want to start from bottom to top when we multiply across, because if you look, that's what goes here. The bottom function times the derivative u prime of the top function. So basically, if you just remember this order for product and quotient rule, it'll always work. Product rule, you can switch it, but quotient rule, you have to do it in this order because it's subtraction, and subtraction is not commutative, so you can't switch the order. So you're going to still cross multiply, but this time you're going to cross multiply and subtract. And then on the bottom, you're just going to square the original denominator. So let's look at how this works. So for this first one, We're going to do both methods again. We'll start off with doing the quotient rule just so you can see. So the top is going to be u and the bottom will be v. So u is going to be x to the fourth minus 2x to the third plus 3x to the second plus 4x plus 5. V will be 2x squared. So take the derivative of each piece. So now we can use a power rule. So we have 4x to the third minus 6x to the second plus 6x plus 4, and then the 5 is just going to go to 0. So then from there, we're going to go ahead and do the derivative of this, which will just be 4x. So now, just like before, bottom to top across. So it's going to be the derivative f prime of x will be 2x squared times 4x to the third minus 6x squared plus 6x plus 4 minus 4x times x to the fourth minus 2x to the third plus 3x squared plus 4x plus 5, because it's the product of u and uv. And then on the bottom, I square the original denominator. And notice I put parentheses because I got to remember to square each piece. So now when I go ahead and simplify this, I'm going to distribute that 2x squared through. So it's going to be 8x to the fifth minus 12x to the fourth, because I'm adding those exponents, plus 12x to the third plus 8x squared minus 4x to the fifth plus 8x to the fourth minus 12 x to the third minus 16x squared minus 20x, all over this whole thing squared, which is going to be 4x to the fourth. So now we want to start simplifying the top. So look for anything that's alike. So 8x to the fifth minus 4x to the fifth is going to be 4x to the fifth. I have negative 12x to the fourth plus 8x to the fourth is going to be negative 4x to the fourth. These are just going to cancel. 8x minus 16x squared will be negative 8x squared. And then a minus 20x. All over 4x to the fourth. And now if I actually go through and divide these, so 4 divided by 4 is 1. Keep the x, subtract the exponents, so it'll be x to the first. These are just going to be negative 4x to the fourth divided by 4x to the fourth is just going to be negative 1. Divide these, you get negative 2x, subtract the exponents, negative 2. And then negative 5x, this is a 1. 1 minus 4 gives me negative 3. So that's the simplified version. If you want to then apply the power rule, so method 2 will be using the power rule. You would first take your function, and remember, you have to get it into that format where you can actually apply the power rule. So coefficients times an x raised to a power. So the first thing I'm going to do is I'm going to take this function and I'm actually going to divide these out. So I'm just going to rewrite first. So basically what I just did, divide. So it's 1/2 x, subtract the exponents, 2. Divide these is going to be negative 1x plus 3/2. The x's are gone. Plus 2. Subtract these, 1 minus 2, negative 1. Plus 5 over 2, x to the negative 2. And now I can apply the power rule. So multiply, you get 1, x, subtract, we just get x to the first. This is just going to become -1. This will just go to 0. Multiply, you get -2x, subtract 1, -2. Multiply these, you get -5x, subtract 1 from that -2, you get -3. So in the end, you should see that these answers are the same. So again, it's your choice how you want to go about it, if you want to use the quotient rule or if you want to use the power rule. In this case, it's definitely easier to use the power rule. It's a lot less steps, but in the end, you want to sometimes use the quotient rule when you can't actually apply the power rule.